alpha beta roots of this equation and to the sequence dia ase a and b n, but a n to directly alpha beta terms ase ei karone moi d and c to agote check korim যে d to swa ki dia ase sigma n equals to 1 to infinity a n by 10 raised to power n. So a n to put korilu jate a n dia asil, so a n put koriba aru jetu constant ase ulai dia sigma respect of n summing variable ase no alpha minus beta to constant etu ulalu tar bisot jetia etu আমি এটা এটাকে পুট কৰিম ভ্যালুজ তে আমি দেখিম এটো ইনফাইনাইট জিপি হয় ঠিক আছে তে ফর্মুলা ইউজ কৰিলো a by 1 minus r ঠিক আছে সিম্পলিফিকেশন কৰিব লাগিব অলপমান কৰি কেনে ইয়াতে এটা এক্সপ্ৰেশন এলসিএম তাৰ পিছত আহিব 10 minus alpha 10 minus beta যেটো সিমেট্ৰিক হয় ফাংশন সিমেট্ৰিক ফাংশন ইন alpha and beta. So directly alpha plus beta and alpha beta values use kori ami ulabo paru. No need of substituting the values of alpha and beta. So alpha and beta, as you know, etu yar para ulabo para hai na 1 plus root 5 by 2 is jabo and 1 minus root 5 by 2. But without using actual values can solve this problem. ঠিক আছে alpha beta asil 1 alpha beta alpha plus beta 1 alpha beta minus 1 ete put korilu 10 by 18 ahil etu correct. তাৰ পিছত আৰু এটা অপশন আছে সি অপশন সি অপশনটো কৰিব কাৰণে ফাৰ্স্ট এটা আমি কাম কৰি ল'ব লাগিব যেটো আমি ডাইৰেক্টলি ক'ব পাৰিলো হয় ঠিক আছে ৰিজাল্টটো আমি ডাইৰেক্টলি ক'ব পাৰিলো হয় ঠিক আছে সেই কামটো কি হয় এটো মই শৰ্টাৰ মেথড কৈ আছো যে x স্কয়াৰ minus x minus 1 equals to 0 ইয়াৰ roots কি আলফা বিটা ঠিক আছে আলফা বিটা স্যাটিসফাই কৰিব এটো আলফা বিটা যদি স্যাটিসফাই কৰিব the alpha square minus alpha is 1, so multiplying both sides by alpha raised to power n we give them alpha raised to power n plus 2 minus alpha raised to power n plus 1 is alpha raised to power n. Similarly for beta ami pai jam. Now ami 1 minus 2 korim 1 minus 2 korim because ami a2 jetu dia ase an dia ase an to ami kiba eta expression ulam ঠিক আছে alpha raised to power n minus beta raised to power n and divided by alpha minus beta. So 1 minus 2 divided by alpha minus beta. ঠিক আছে এইটো হৈ যাব কি এইটো তো an পাই যাম আৰু এইটো কৰি চাবা এইটো কি পাই যাম an plus 2 ঠিক আছে this is an plus 2 minus of this is an plus 1 ঠিক আছে এইটো যে বনিলে এইটো an plus 2 is equals to an plus 1 এইটো এটা particular type of recurrence relation হয় এটো recurrence relation Fibonacci relation বুলিয়া কয় Fibonacci relation sequence কি হয় যে any term except the first and second term is the sum of the preceding two terms ঠিক আছে so whenever a sequence is generated using linear combination of alpha raised to the power n and beta raised to the power n, okay, that sequence will always satisfy this recurrence relation ঠিক আছে so directly we could have said this without doing all this okay because since an sequence is generated by using linear combination of alpha raised to the power n beta raised to the power n and alpha and beta are not just roots of any equation any quadratic equation alpha and beta has to be the roots of this particular equation only ঠিক আছে then only this point that I discussed is valid okay so after finding this okay what we can do here is n equals to 1 to n an is required okay we have to comment about this C option this is sigma n equals to 1 to n an okay so just simplify this okay and you can do simplification like I have done in method 2 okay so you can go through method 2 also okay kinto I prefer this method okay because it's simpler okay See, here what I've done, I've deliberately added a2 here because what I need in the option is কি লাগে an plus 2 minus 1 লাগে তে মানে ইমান terms আছে I need only 2 terms, so what I'm doing, I'm adding a2. Okay, so a1 plus a2 will give me a3. Okay, from this. Okay, because I know this sequence will satisfy this Fibonacci relation. Okay, so sum of a1 and a2 will give me a3. Then a3 will add with a2 and it will give me a4. Okay, so then a4 plus a3 will give me a5. Like that, a5 plus a4 will give me a6. Okay, so at last an will be added with an plus 1, that will give me an plus 2. So what is sigma n equals to 1 to n an? It is nothing but an plus 2 minus a2. Okay, now what is a2? A2 ulai labo para. What is a2? A2 is alpha square minus beta square by alpha minus beta from the definition given in the question. Okay, so here we are left with only alpha plus beta, that is we know is 1. So this second is also proved. Okay, so we got these two options, D and C. Now we are left with B and A. Okay, so uh, before jumping to A, we'll have to because we don't know about anything about Bn with respect to alpha and beta, so let me B option and sum. Bn is alpha raised to power n plus beta raised to power n. So what is Bn? Bn is given as an minus 1 plus an plus 1 for n greater than equals to 2. So an minus 1 just substitute করে দিলো তাতে and an plus 1. Okay, and তাৰপিছত আমি alpha raised to power, এটা important step, ইয়াতে alpha raised to power n common লৈছো because আমাক কি লাগে, আমাক bn লাগে alpha, we want to prove this alpha raised to power n plus beta raised to power n. So denominator at 1, that means from here we need a factor of alpha minus beta, then only we'll get the denominator as 1. So that's why I've taken alpha raised to power n common and from these two, and then from here beta raised to power n, and I've used the alpha beta is minus 1, so 1 upon alpha is minus beta, so I have substituted 1 upon alpha is minus beta and 1 upon beta is minus alpha here. So if we take alpha minus beta common, okay, and then we'll be left with alpha raised to power n plus beta raised to power n. So this proves the B part also. Okay, and for the last part, it is A part, just we proved, okay, that Bn is alpha raised to power n plus beta raised to power n. We'll substitute here. Okay, and we'll find that this is again infinite GP. Okay, so we'll use the formula use kora again, similar calculations. Okay, like in the D part, just here we'll have a plus. Okay, again using alpha plus beta values and alpha beta, we'll get 12 upon 89. Okay, so only options B, C and D are correct. Okay, A is incorrect.